Okay, so we are here, right? Everybody have their notes back out from Friday? Let's just do a quick recap of what we talked about, okay? Angles in standard form, really standard position is normally what I say. I don't know why I have standard form written everywhere. It's really the same thing, but we talked about degrees, we talked about radians. We're going to talk about degrees just a little bit more today, but then really we're changing and kind of everything is going into the radian world, all right? And you will become a believer very quickly. You still may not be by the end of today, and I understand that, but I'm going to get you there so that you understand that radians are actually a whole lot easier to think about, especially in the ways that we are going to use things, and you'll become comfortable with them. It'll all be okay. One thing that I did want for you to be able to start thinking about. Remember, I was challenging your brains, and this whole set of notes is better done all in one day, because then we would have at least, this would still be fresh in your mind. Is somebody at the door? Okay. I can't ever tell because when I'm talking if I can hear the knocking or not. Thank you. Anyway, then I want you to kind of think around the circle. So remember, we thought we were trying to think fractionally around the circle as we went through these. We're going to do that again today. When we get to that point, I'm going to tell you right now, I'm going to ask you, does everybody understand what I mean by that? And if you don't, and you don't speak up, I can't help you, okay? Like, I've got to know before I move on. I don't want you lost in la la land, and then you're going to be confused forever. We don't want that, okay? So let's talk again about, we're going to start back with degrees to try and help make everything make sense. And we're going to talk about, excuse me, coterminal angles. So coterminal meaning with or together type of thing. Terminal where it terminates. Excuse me. Hopefully I won't be coughing through the whole list. All right, so if I have, remember we start here at 0, right? I'm afraid I can't talk without coughing now. If I want my terminal side to be here, I can get there in two different basic ways. If I start at 0, I can go a positive 90 degrees and get there, or I can go a negative 270, and the angle would look the same without the little arcs that show you which way to go, right? We looked at some of those yesterday, or Friday when we did that. If you think about it as like running around a track. If we all started here at 0, and we had to make it here, I guarantee you I would choose to go in this direction because I want to run as little as I possibly can. Some of you may actually choose to go the other way. Some of you may choose to go this way, and by the time I make it here, you will have lapped me and still made it to the exact same spot, okay? And some of you might go around a few times and lap me before I make it there, depending on how slow I want to actually walk or run. But there's basically an infinite amount of ways for me to end up here, right? Because I could go 360 plus 90, I could go 360 and 360 and 360 and then 90, and I could still end up there, right? So an infinite amount of ways to make an angle end on the positive y-axis. You with me on that? And so there's an infinite amount of different angle degrees I could write out that would be a coterminal angle. We're going to make this a little simpler, and our answers are going to have to be between 0 and 360, or between 0 and 2 pi. The 2 is missing out of there. Pi doesn't really make any sense because you wouldn't be able to answer some of these questions. Okay? So, let's start with 544. 544 is already more than 360. We know that for sure, right? And so if I want my angle to be between 0 and 360, I can do one of two things to get here. Okay, let's just pretend like it's here, which we know that it's not. To get here, I can either add another 360, or I could subtract 360, right? And I'd end up in the same spot. So I'm going to take 544 and I'm going to subtract 360 degrees. When I do that, what does theta equal? Anybody tell me? 184. Good. That's 184 degrees. Now, is 184 degrees between 0 and 360? Yes, so then we're good, right? If not, we might have to subtract again, or subtract again depending on how big the angle is. You with me on that? So 544 degrees and 184 degrees are coterminal angles. Remember back here, in the way back times we did, where was it? That was when we were doing these, right? This 135 that we graphed, and then we graphed 495. when we subtracted 495 minus 360, we got 135, right? So these two angles, the 495 and 135, those are coterminal because we ended up in the same spot, right? Just added another 360 there. Okay, so now let's look at negative 170. That's clearly, again, not between 0 and 360. So if I was going to go a negative 170, and this time I would need to add the 360 to make it positive. So if I add 360, that's really just like 360 minus 170. What does theta become? 190. Y'all agree with that? Okay. So you're just adding or subtracting 360. Now we're going to look at radians. 360 degrees is how many radians? All the way around the circle in radians. You can flip over your notes if you need to. I'm just going to throw that out there. It's what? It's 2 pi radians, yes. Okay, so if I'm here, this is 0, so this is 0 and 360, or 0 and 2 pi. Okay, 2 pi radians, right? Now, if we're thinking in terms of halves, because we're going to think fractionally again, so remember, if this is 0 and this is 2 pi, this is pi, right? This is pi halves. So these, for 12 and 13, we're talking about something halves. So we're going to think fractionally in halves. So 0, this is pi halves. This will be 2 pi halves, right? 3 pi halves, and 2 pi is actually what? How many pi halves? This is 1 pi half, 2 pi halves, 3 pi halves, 4 pi halves. So would you agree that 4 pi halves is equal to 2 pi? Yes? Right? So when we're thinking fractionally, because these are in halves, yes, it's 2 pi, but I need to think about 4 pi halves. You with me on that part? Okay, so that I can make everything. It's kind of like getting a common denominator without having to think, like, I'm getting a common denominator, and then your brain wants to shut down because you're thinking about fractions, right? It's not nearly as complicated as we need to make it out to be. So 11 pi halves. Do you think that that is more or less than 2 pi? More, because if I actually divided, I did 11 divided by 2, that's 5.5, right? That's more than 2. That's all I really care about. So I'm going to take this, and so I'm going to have to subtract, but I'm going to do the halves, minus 4 pi halves. That's going to give me 7 pi halves. Now remember, our answer needs to be between 0 and 2 pi. Is 7 pi halves between 0 and 2 pi? No, because 7 divided by 2 is 3.5, right? So it's more than 2 pi. That's how you can kind of figure it out easily, right? So that means I need to do what then? Can I subtract again? Basically, I'm taking the circles away, right? So I'm going to subtract 4 pi halves again. That's going to give me 3 pi halves. Is 3 pi halves between 0 and 2 pi? Yes, so that is my answer. Okay. So that means 11 pi halves, 7 pi halves, and 3 pi halves are all coterminal angles. They all end right here, right? So this would be 3 pi halves, and then 7 pi halves, and then 11 pi halves, because I just keep adding that 4 pi halves to it. Make sense? How many rotations we're going there. Now let's look at negative 5 pi halves. Clearly, not between 0 and 2 pi, because it's negative, right? That one's a whole lot easier. So what would I do here? Add. I'm going to add 4 pi halves. So I'm going to add 4 pi halves. That's going to give me negative pi halves. Still not between 0 and 2 pi, right? So I'm going to do that again. Plus 4 pi halves. And that gives me that theta is equal to 3 pi halves. So not only is 3 pi halves and 7 pi halves and 11 pi halves coterminal, but so is negative pi halves and negative 5 pi halves, right? Just different ways to get to the exact same spot. Okay? You're just adding or subtracting a full rotation. Everybody okay at this point? Right. We are not doing this part because we don't need to. It's important for you to understand what a coterminal angle is, and that it's one full rotation away. The actual math behind it, we're not going to necessarily, with the degrees, we're not going to pretty much do it all. But with the Radians, you're not going to do it much. You just need to basically understand the concept. But reference angles, hugely important and not that complicated to figure out here. So for an angle theta in standard form or standard position, the reference angle is the positive acute angle, that should say formed, by the terminal side and the x-axis, okay? Not the y-axis, the x-axis. We're going to sketch each angle and find its reference angle. So if you look over here, here's my angle. This is theta, okay? We talked about how to graph them on Friday. Basically, the way you want to think about this is the shortest way back to the x-axis. That's this right here. That makes this the reference angle. If our angle is theta, our reference angle is alpha. Okay? Alpha is kind of the generic, that's what most, anytime you're talking about reference angle, we just refer to it as alpha. So to write it, it is the lowercase alpha. The capital alpha looks like a capital A in the English alphabet. That's awesome. The lowercase alpha looks a lot like the lowercase a, but it's not, and I want you to make an honest effort to make it into the Greek letter. Now, when I write it quickly, it's going to get sloppier and sloppier, and that's okay. But if I was going to do it slowly and nice and pretty, see, and I can't even, that even looks too much like an A. It is, I think the best way to explain it is it kind of looks like a fat Jesus fish. That's the way I draw it. Okay, y'all know what a Jesus fish looks like, right? So it's kind of like a fat Jesus fish. Nice, pretty Jesus fish would be pointy, but you can just kind of draw it like that, okay? Close enough. I just, again, want you to make an honest effort, so we're trying to be intelligent mathematicians to the best of our abilities, okay? All right, so we're going to do a few in degrees, but I'm going to tell you on your assignment, they're all in radians, because I want you to be able to think that way. I'm doing a few in degrees so I can make sure you understand what a reference angle is. Then we will move on to the radians and go from there, okay? So we're going to, it says to sketch the angle. So first, 150 degree angle. So I'm here. I know I start there at 0. Same thing we did on Friday. 150 degrees is going to be in which quadrant? Second, okay? And so I'm going to go, I go 90 and then how much more? 60, okay? And so 60 is like 2/3 of the way through the quadrant. So again, we just make an honest effort to look like we try to do 2/3 and we know it's past halfway, something like that. My terminal side isn't even completely straight. That's okay. Theta is equal to 150 degrees. So that's the exact same thing we did on Friday, just graphing the angle. Now, the angle, this angle that we just drew is in standard position. Your reference angle is not always in standard position, and that's okay. It doesn't have to be. We have to make sure it's always positive and always acute, which means it doesn't matter which way we go to get there. Whether it's clockwise or counterclockwise, it's still acute. I'm sorry, of course it's acute, but it's still positive because it's not in standard position, so that stuff doesn't matter as much. The shortest way back to the x-axis is like this. This right here is your reference angle. So what would the measure of that angle be? 30, right? So that means this is alpha, and it's equal to 30 degrees. Always positive, always acute, always the shortest way back to the x-axis. Okay? Everybody good with that? Yes, sir. Uh-huh. It's theta. It's a circle with, it's the Greek letter theta, yeah. All right, everybody else, okay? So we are looking at 315 now. I know I start here. What quadrant would 315 be in? Fourth, okay? Because I know like this is 0, 90, 180, 270, 360, so it's somewhere in here. Now, you can come up with where we end up in the fourth quadrant a couple of different ways. We know that this is 270, or at least we should, but if you don't, in all honesty, it doesn't matter because we're about to get rid of degrees anyway. 270, and then I can figure out how much farther I have to go. Or you can think about it as, excuse me. Sorry. You go all the way to 360. I haven't quite made it like how much farther do I need to go to get to 360? I suggest, because this is what I'm going to have you do with the radians, it's going to make it all easier, is always think on the x-axis. So instead of taking 270 and how much farther, which is what we basically did here, right? 90 and how much farther, which there's nothing wrong with it. In degrees, it makes sense. In radians, it's not always going to be as easy that way. But let's think about it this way. If I went to 360, I'd have to back up how much? So what's 360 minus 315? 45. So that means I'm halfway through the quadrant, right? So I'm here. Close enough to halfway. I draw this, and then my theta is equal to 315 degrees. Okay? Everybody okay with that? And by doing it that way, by thinking from the x-axis, we've already answered the next question, even though you might not realize it. What's the measure of the reference angle? How much did we back up? 45. So alpha is equal to 45 degrees, right? If you always measure from the x-axis, you've already answered your reference angle question. Okay? Everybody okay with that? Okay. So let's look at negative 240. So I'm here. Negative 240 is going to be in what quadrant? Second. Good, because negative we go clockwise, right? So we end up here. And again, if we're going to go from the x-axis, I would go negative 180, and then how much farther? 60, right? So 60 is it is 2/3 of the way through. So this is, theta is equal to negative 240 degrees. Right? So then here's my reference angle. And we already said we went 180 and then how much more? 60, right? So alpha is equal to 60 degrees. And I know it was a negative angle, but remember, it doesn't matter because your reference angle is not in standard position. You are just concerned with the positive angle measure of whatever it is, wherever it is. What questions do you have at this point? We're all good with reference angles. Okay. All right, so now we're going to talk about the radians. And these three angles, now on the front when we converted and did some stuff, I didn't make sure that they were our special angles that we have to know. These are, you don't recognize them as that yet, but that's okay. But because of that, there's some values that I want you to know. And so I want to think about, we're going to look at pi sixths, pi fourths, and pi thirds. Okay? So let's talk about pi sixths. If I go from here to here, that is 6 pi sixths, right? From here to here, around this way, 6 pi sixths. So if I go just one of those, if I just go pi sixths, I've gone 1/6 of the way of 180. What's 1/6 of 180? 30, right? So pi sixths is 30 degrees. If I'm talking in, let's just talk about halves first. If this is 0, this is pi halves, right? If I cut that in half, I get pi fourths. What's half of 90? 45. So pi fourths is 45 degrees. Pi thirds, from here to here would be 3 pi thirds. Pi thirds is just 1/3 of the way. What's 1/3 of 180? 60. These three conversions you need to know, and then everything else is just going to come together from that. Okay? We did do some actual conversions with the little formula. That is something that may have to happen, but we're not going to do a ton. If you know this much, we can think in terms of radians and kind of be done with degrees. The only reason we really want to know these is just to kind of help you wrap your mind around things and make sure you're putting things in the right place, especially when you're graphing. But make a note of this. You've just got 30, 45, and 60. Those are your special angles from your special right triangles, right? And then the pi sixths goes with the 30, and the pi thirds goes with the 60. So like the 3 doesn't go with the 3, and the 6 doesn't go with the 6. Okay? And then you should be able to keep them straight pretty easily. All right? And that'll kind of help us graph this here. So let's look at 5 pi thirds. First of all, we're going to graph this, and we're going to think of the circle. We don't have to think in terms of degrees to do that, to be able to figure out what quadrant we're in. We know we're going to start here. If I go from here to here, this is 3 pi thirds, right? If I go all the way around, how many pi thirds is it? 6 pi thirds. Okay, so does everybody understand that thought process right there? That's the most important part. We're just thinking because the 3 pi thirds is just pi. So 3 pi thirds, 6 pi thirds, right? So if I'm here at 0, 3 pi thirds, 6 pi thirds, I want to be at 5 pi thirds. So if this is 6 pi thirds, if I just back up pi thirds, wouldn't I be at 5 pi thirds? Okay, because if this is 3 of them, think of them as things. This is 3 of them, this is 6 of them. One less than that gives me 5 of them, which is what I want, 5 pi thirds, right? Okay, so pi thirds is how many degrees? 60, right? So that helps me know where to put it. That's kind of the most important part there. It's about 2/3 of the way through here. Something like that. I just drew it in the exact same spot. It's fine. So this is theta, which is 5 pi thirds. Okay. So then, again, we just answered our question for our reference angle. This is our reference angle. What do you think alpha is equal to? How much do we back up? Pi thirds, yeah. 1 pi third, which is just pi thirds, right? We backed up one of them. So 5 pi thirds plus another pi thirds gives me 6 pi thirds, right? You see how to think fractionally around there? I know you're still not going to love it. I know you're still not going to maybe not feel like an expert when we're done today, but that's okay. I don't expect you to. I just wanted to start making a little bit more sense. Again, it would have been helpful had this all been done one day, but life doesn't always work out the way we think it should. So just didn't work out that way. So let's look at 13 pi 6. Now we're thinking fractionally in terms of sixths. Just hard to say. So I'm here. I go right here. This is 6 pi 6. So what is this? 12 pi 6. So then I have to go how much more? 1 pi 6, right? And pi 6 is how many degrees? 30. So it's about 1/3 of the way through the quadrant right here. So should I go all the way around like this? Theta is 13 pi 6. Now, when we did this, and I think I already kind of said this, but when we did this graphing on the front, I used like 18ths and some other things, and I kind of regret that now. These are the angles that really are going to make the most sense, the ones we're going to use over and over again. So they are a little bit easier to graph and think about that way. So then here's my reference angle, shortest way back to the x-axis. So this is alpha. What does alpha equal? Pi 6, right? Because we went to 12 pi 6, then one more of them. Everybody okay with that? Your reference angles are what we're going to think about, because when we start talking about these angles, well, I'm getting ahead of myself. Hang on a second. Let's finish this, and then I'm going to let you look at some, and then I'll say what I was about to say. Negative 5 pi 4ths. So I start at 0. It's negative, so which direction do I go? Clockwise or backwards, yeah. So I'm going to go, this is 0. This will be 4 pi 4ths. So how many more do I go? Yeah, 45. I go pi 4ths, which is 45 degrees. And I end up right there. And theta is equal to, just the notes from Friday. So is equal to negative 5 pi 4ths. Oh, that's a 4. I don't know what's going on with the board. Sometimes it skips. There we go. Negative 5 pi 4ths. So then what is your reference angle? What would alpha be? Pi 4ths, right? And it's positive because remember, I don't care which direction we went. It's always positive. It's always acute. Okay. Everybody okay with that? What questions do you have? Don't be afraid to ask a question. All right. Now, I want you to look at these 6 angles that we just did. And I want you to look at how the degrees and their reference angles relate and how the radians and their reference angles relate. Okay? If you were to ask me what the reference angle is of something in degrees, I am first going to have to figure out what quadrant it is in and then do some subtraction or addition or whatever. If you were to ask me of our special angles, what quadrant or what is the reference angle for 17 pi thirds, I can tell you like that without looking at anything. Because look how the reference angles relate to the actual angle. You see how the denominators are the same? If you ask me, what is the reference angle for 17 pi thirds? It's pi thirds. No question. I still am going to have to think about what quadrant that would be in, but if all I need to know is the reference angle, it's a piece of cake. All of these, for 5 pi fourths, it's pi fourths. For 13 pi 6, it's pi 6. For 5 pi thirds, it's pi thirds, right? So when we get into this stuff and I ask you things about 23 pi fourths, you know your reference angle is pi fourths, and then we just go from there. I'll give this to you when we're done. What the heck is this for? Why are I missing class? Okay. All right. Any questions about that? So remember, on your assignment, I didn't put any degrees. It's all in radians. And I really want you to start thinking about that. The main reason I want you to know these, well, there's a few reasons, but right now, just so it can kind of help you draw it in the right spot. You're not using these values to help you figure out what you wrote down. It's more about where to put your terminal side. Okay, and then those will be helpful in the future for some other things. Okay, we good with that? Any questions? All right, now, we talked about quadrants here. I said, what quadrant are we in? What not? Well, what if you don't land in a quadrant? What if you land on an axis? Then you have something called a quadrantal angle. So when the terminal side of an angle that is in standard position lies on the x or y axis, then it's called a quadrantal angle. So if I'm at 0, or if I'm at 2 pi, or 4 pi, or 6 pi, or negative 2 pi, whatever, and I said, what quadrant are you in? You can't say 1, 2, 3, or 4. Your answer would be quadrantal, and it's on the positive x-axis. Okay, it's a quadrantal angle on the positive x-axis. Okay, so quadrantal in itself isn't enough because it could be on any of it can be in 4 different spots. So if I am at pi halves, or 5 pi halves, or 9 pi halves, or whatever that gets me there, or even negative 3 pi halves, then, and I'm asked what quadrant it's in, my answer would be quadrantal, and then I would have to say positive y-axis. If I'm at pi, and I did leave the degrees on here just because I know they still make a little bit more sense to you. If I'm at pi, or 3 pi, or 5 pi, or negative pi, whatever, I end up there, then it is quadrantal, and it is on the negative y. Oh, that is not the y-axis. Negative x-axis. Okay. Because it's the negative x's. I'm talking about an axis. Then if I'm at 3 pi halves, or however else I can get there, negative pi halves, then it is quadrantal on the negative y-axis. Okay. What questions do you have? Anything? Okay. Good deal. Then if you don't have any other questions, then you can go ahead and tape this in. You should have your assignment from Friday. You have the rest of the time to work on that. And yeah, make good use of your time. Looking for pause.